right. Hi, folks. Let's see. Can y'all see my screen? All right, cool. Yeah, I guess it is 2 p.m. Eastern on the dot. So it's 2:01 now. In any case, we can probably get started. If my screen's flashing at all, please tell me, because I know for whatever reason my computer's been acting a little funky on Zoom, but it seems like hopefully it's all right for the time being. But in any case, yeah, I guess Jordan and I, we can introduce ourselves real quick and then we can get started. But hi, everybody. My name is Juliet Eldred. I'm a project manager at Trillium, which is a firm that mostly works around building GTFS feeds. A lot of you probably know me actually from the large Facebook group that I run, as well as perhaps Twitter. But for now, I will be here on work-related purposes and talking about GTFS data, and in particular, the National Transit Map, which is a project that I've been working on for the last couple of months. And so, Jordan, if you want to introduce yourself.
Sure. Jordan Riddle. I'm a statistician with the Bureau of Transportation Statistics, and really excited to share the National Transit Map with you all, and appreciate you for sharing your lunchtime with us.
For sure. Yeah, definitely appreciate that. I know there's been a lot of good talks and stuff earlier today, but yeah, we appreciate y'all spending your lunch break with us. So yeah, I guess let's get started. Let's see if it'll, there we go. Cool. So basically we're dividing the presentation into 4 parts, technically really 2 parts, but the first 3 parts are all part of the, that's what we have the slide deck for. We're going to start by talking a little bit about the GTFS spec in general, talking a little bit about its history and sort of what files actually comprise it, sort of what its part, what are its constituent parts. Words are hard, sorry. And then next we're going to talk a little bit, Jordan will talk a little bit about the National Transit Map program, a little bit about its background and some stats on its agency participation and outreach that we've been doing for it. Then we'll go into some interesting uses of GTFS data among, other agencies and apps, things like that. And yeah, okay. Weird. Hopefully it's a Zoom related issue, just looking at the chat. In any case, then after we talk about interesting use of GTFS data, we're going to talk about the sort of method that we've been working on putting together, which is how you can use GTFS data in GIS programs. In this case, we'll be working with QGIS. That's the open source spatial analysis program. And so basically what we'll be doing is talking a little bit about some of the particular GTFS files you'll need to actually do this process, and then talk a little bit about walk through the steps that are actually required of it. I've also put together a little PDF which has a tutorial or just the steps of the tutorial, so you guys can go through that at your own kind of follow along at your own pace. And also if you want to try these processes on your own, you have a pretty easy way to refer back to it. So yeah, I guess we can dive in now. So what is GTFS? GTFS stands for the General Transit Feed Specification. And it's basically, at its core, it's a set of text files that contain schedule, stop, route, and fare information about the transit agency service. And so basically, it's a transit service data format that can be read by trip planning apps, like the ones pictured on the right, like Google Maps, Apple Maps, Transit, Move It, all sorts of other apps. And so it's published by close to 1,000 agencies in the United States. And if not more, Google doesn't really publish necessarily a number of everyone in Google Maps, but based on our own research, things like that, we've been able to determine that a lot of agencies have GTFS in some way, shape, or form, and it's used by 100+ other public transit apps worldwide, as well as lots of other kinds of uses, which we'll be going into over the course of this presentation. And so, as I said before, GTFS feeds basically are a set of text files that are zipped together in a folder. And so these are the ones that are required as part of the feed spec. So basically agency.txt, it's just, the name of the agency, some basic information about the agency itself, then stops.txt, which has the IDs of the stops, but also their lat-long coordinates. So this will be very useful when it comes to actually mapping things, because obviously you need some geographic coordinates to actually map things. And then you've got routes.txt, which has the names of the different routes and their names and the colors that they should be displayed as on the trip planning app. Crucially, routes.txt does not actually include any lat-long information, it's just informational. But shapes.txt is a optional file. We'll go into that later. In any case, you're not going to be quizzed on any of this, you need to remember it. But in any case, these are all the required files of the GTFS spec. So every feed will have all of these. Calendars can get a little funky, but there's no reason to go totally into the get super technical at this point. There's a lot of different optional files that are included that can be included as part of a GTFS feed, but aren't required necessarily. And so the shapes.txt is a big one. These are the actual route alignments, and they consist of, quote unquote shape points, basically just like lots of different points that create the that are strung together to create the route paths. There's also additional information about fares, as well as pathways and levels. That's more of information that's useful for like larger train stations or bus stations where there's multiple different platforms within, and can show sort of where the vehicles stop in relative to those things. But yeah, so these are the optional files. There's also the GTFS real-time extension, which I think that Kona talked about in his presentation earlier. That's sort of real-time data. That's what you might be most used to seeing on trip planning apps, but we'll be focusing pretty much exclusively on static feeds for this presentation. So here's how a lot of this information actually shows up in trip planning apps. And so as you can see on the right, here's a trip from Columbia Heights Civic Plaza down to US DOT headquarters in Navy Yard. You can see it has like the actual route itself and the stops within, and has frequencies, things like that. Similar information in middle photo, that's a transit app with some frequencies of the F92 bus from that particular location. And then on the right is the Apple Maps, and it just shows some also like the combination of real-time and static data, things like that. And yeah, so basically this is sort of how these text files this is where they end up. So a little bit of history about the GTFS specs. So basically the problem was, while driving directions in the early era of digital mapping in the early mid 2000s, they're pretty common. Transit trip planning was a lot harder to find. So generally, if you actually wanted some trip planning online, if some agencies had their own apps or like trip planning options on desktop, but they generally weren't where people were used to looking for directions. Places like, Google Maps, Yahoo Maps, and MapQuest. We got a nice little screenshot here of MapQuest circa 2005. This is what we were working with at the time. And so basically, it meant that like it was much harder to navigate by transit while you were traveling or in a place that was unfamiliar to you, or in cities that may have multiple systems and interagency transfers, things like that. So starting in 2005, a group of TriMet staff and Google engineers worked together to come up with a way to structure transit schedule data into a format that could be read by Google Maps. And so this was originally called the Google Transit Feed Specification. And adoption of this standard was initially pretty slow, but eventually it snowballed. And by 2010, there were over 100 US operators that were in Google Maps, and hundreds more have been added since then. And the entire ecosystem has kind of developed around this particular data spec. And so eventually it was changed to the general transit feed specification to reflect its open source nature and use in a variety of applications beyond just Google. So I think I'll hand it over to Jordan now and talk about the National Transit Map. And yeah, Jordan, just tell me when to advance the slides.
Sure, thanks, Juliet. So before we dive in, for those who aren't familiar with the U.S. Department of Transportation Bureau of Transportation Statistics, we're one of the 13 principal federal statistical agencies. So you might be familiar with like Census Bureau, Bureau of Labor Statistics, and the National Center of Health Statistics. So as a principal federal statistical agency, we are an objective supplier of statistically sound baseline, contextual, and trend info used to shape transportation policy and investment decisions across the US. So why BTS and the National Transit Map? So transportation's fundamental role is connecting people and places. So the department recognized a gap in understanding the full reach and limitations of transportation in America. And this is particularly with transit. So by combining transit data into the National Transit Map, we'll be better equipped to understand and illustrate the role of transit in America, understand where gaps in service exist, and help connect Americans to opportunities. So what is the National Transit Map? And here on this slide, we've got the homepage pulled up there, and I dropped a link to the landing page in the Zoom chat in our Slack channel, so you can access that. So the National Transit Map made it possible for US DOT to collect scheduled data from a large number of agencies. It's an open data compilation of stops, routes, and schedules from fixed guideway and fixed route transit service. And I should reiterate, that is fixed guideway and fixed route. So it's not the real-time GTFS. So since its release in 2016, researchers have used the National Transit Map to illustrate the role of transit and examine transportation networks, how they work together. And again, understanding how these networks are integrated helps us better connect Americans to family, healthcare, opportunities, and recreation. So if we can go to the next slide here, we'll dive into how we get data for the National Transit Map. So DOT is leveraging data that transit agencies already make available to the public, and Juliet had just covered the GTFS feed. So we don't require transit agencies to produce any new data. This is an entirely voluntary program. So rather, transit agencies that are already providing this info as open data will be able to participate with little effort. Again, we aim to keep this level of burden as low as possible. So we work with our colleagues at the Federal Transit Administration on this effort, and we make use of their FACES portal, which the agencies are already familiar with using as reporters to the National Transit Database. So we make use of an existing platform to get them to voluntarily register into the National Transit Map. So these agencies generously grant us access to their data, which allows us to collect and aggregate and publish a geospatial service that, again, describes the state of America's transit services. And on this next slide, we'll dive more into geospatial services. So this is a screenshot here of our National Transportation Atlas database, which is BTS's nationwide geographic database of transportation facilities, networks, and infrastructure. So with GTFS, BTS hosts an index of participating agencies and a catalog of transit stops and routes. So I also put those in our Zoom chat here. So we'll share those resources for you all. You should have at the top. And we'll jump into the next slide here and look at participation. But before we do that, I wanted to touch on this parallel effort. So this is the Intercity Bus Atlas. And as you can see here on this screenshot, this project also makes use of GTFS, but as the name suggests, these feeds come from intercity bus operators. So rather than using the FACES portal registration, these intercity bus operators enter into an MOU with us. And so as the visual here demonstrates, this is what a more complete network can reveal with local and interregional transportation patterns and inform the nation about location and connectivity of its transportation facilities and services. So we're going to jump to the next slide here and look at connectivity for the National Transit Map. So again, this was back in 2016 before we jumped to these numbers. In 2016, Secretary Anthony Fox then announced the project in March by asking our agencies to voluntarily submit their data about their routes and schedules. And that response yielded around some 270 transit agencies. So you can see here that we've grown quite a bit since then. So that 270 was about a third of all urban US transit agencies with fixed route service. And so we've got 400 and counting now. So these other metrics here that you see with the geography and the vehicles operating maximum service and the passenger trips are all different kinds of ways that we seek to advance connectivities for our stakeholders of the National Transit Map. And we'll jump to the next slide here and look at some maps that Juliet prepared for us. So we've got participation by state and percent of participation by state. So what's important to look at here and understanding which agencies have GTFS and within that universe, which are participating in the National Transit Map, this sort of gives us an understanding of which agencies could be participating and which agencies in our future efforts need assistance with GTFS creation. So again, there are about 2,200 reporters that report to the National Transit Database, which is again, where we get folks to register through the FACES portal. And then of that 2,200, there's about 1,200 fixed route bus services. And of that 1,200, there's probably around 600 with feeds. So as we look at advancement, let's go to the next slide here. Right, so with Trillium's help, we've increased our outreach efforts. So this past September, DOT sent out an email to transit agencies again about the National Transit Map. And other outreach efforts we've done is just simple takes on identifying which agencies have a feed and just simply haven't joined, and then conducting follow-up outreach with those, up to more coordinated efforts, working with states for statewide authorization. So as we see here, we've got about 100 new agencies that joined us, and we're counting on more. And as the project progresses, we'll also have some ongoing and planned work ahead of us. And we jump to the next slide here. So our upcoming work, this is going to include some QA, QC. We're working on a Socrata-based index that we hope makes for easier storing of historical data and making downloading easier for researchers. And it also includes some educational efforts. And this is just kind of quick tips on how to best host your feed. So on the educational note, we'll jump to the next slide here. So we're working on an entry-level GTFS resource. And for most of us on the call, maybe there's even a span in the room. I think I saw that, GTFS is new for some are more on the technical side, been using GTFS since its creation. So this resource is kind of a 101. It'll be entry level. We noticed that there was a gap that most of the resources that are out there kind of aim on the technical side. So this should be more approachable level for all users. And as you can see in the screenshot here, it's still under works, but we're excited to release it soon and hope it's an inviting and valuable resource. So I just want to end on a note for this part of the presentation that data is most powerful when we put it into practice. So I'm going to pass it on to Juliet, who's going to share how you can translate this important data for better understanding the role of transit and examine transportation networks, how they work together.
Right, awesome. Thank you, Jordan. Definitely useful to have some background on the actual program and its goals as part of its role part of VSDOT's broader goals. In any case, I'm going to move on to another sort of aspect of GTFS data where it can be used for trip planning apps, but it also has many uses sort of beyond that, or also even within trip planning apps, there's a lot of really interesting applications of it. One particular example is the MetroHero app. This is an app for that a developer created for WMATA, which is Greater Washington's Washington DC's transit agency. So basically, it's a mobile and desktop app that uses WMATA's GTFS static and real-time feeds to let you visualize your commute in multiple different ways. You can see real-time vehicle locations as well as station-level arrival times, service alerts, things to that effect. And also, you can set your own morning and evening commutes for easy access to information you're most likely to use. Like here in the first image, you can see that we set the evening commute here for Navy Yard to Columbia Heights and in Washington, D.C. And so here, let's know there's a couple of elevators and escalators out at Navy Yard, and that any of the relevant alerts. One thing I also like about MetroHero in particular is that we'll also add in if people have been tweeting about a particular station or route, stop, etc. It'll have the sometimes it'll include relevant tweets, which for DC in particular, which is perhaps been more prone to becoming in flames than the average American transit station. That is oftentimes a useful feature to have. It also lets you track live departures, things like that. And also there's pretty extensive analysis opportunities in this app as well. It lets you look at current and historical agency data. You can even create a live performance audit of headway adherence by stop or route. Here, this is the desktop homepage, and so it shows you some pretty detailed stats for each of the rail lines in a WMATA system. Like you can see on the day that I took the screenshot, Red Line's not doing too well with 65% of trains adhering to the actual scheduled departure and arrival times and all that. So Green Line doing a little better, but overall not necessarily a best day to be on transit. Another tool that exists for that is based in GTFS data is TNEX, which I think it's an acronym for the Transportation Network or Transit Network Analysis Tool or something of that sort. But in any case, it's a browser-based tool that was created by the Oregon Department of Transportation, or ODOT, that allows users to view GTFS data for all the agencies in the state. And so it worked because Oregon has GTFS for, I believe, pretty much every transit agency in the state. There may be a couple of stragglers, but they have very comprehensive GTFS coverage, which is what allows a program of this depth to exist. And so it also integrates census data so that users can generate reports about agency services and their service areas, include basic stats about the agency themselves, like how many routes they run, how many stops they operate, and also how many different geographic levels they serve. So here, this example Corvallis Transit System, they serve one county, one census designated place, one urban area, 2 congressional districts, and 2 transit regions. But some of the other agencies that are kind of more regional, larger agencies like TriMet would definitely have bigger numbers there. But and there's also even more kind of granular data around demographics, things like that. So there's a lot of ways you can kind of use GTFS data as kind of a jumping off point to work with other stuff that can tell you some pretty interesting stories about transit service. So Yeah, so now we're going to switch gears a little bit once again to what we're calling the GTFS to GIS process. And so essentially this sort of process has three kind of main steps, which is basically you're taking schedule data, which in its sort of most raw form is just a set of text files, as you can see here on the left. It's just a bunch of notepad files, and then sort of take it into, aggregate it in a form so it's aggregated at the stop level. In this case, import that into QGIS and visualize the actual daily frequencies from this data. So basically, this process is sort of meant to be a sort of starting point to actually getting your data into, or taking the sort of temporal data that's a little bit sort of gnarly to work with when you first think about it, so taking that into a form that can be used in a GIS program and then doing whatever you want from there. So we're not going to go into a ton of depth on necessarily stuff you can do like analysis-wise with this data, because basically what we want to do is to demonstrate, all right, here's how you go from point A to point B in terms of taking this one data type, putting it into another form where you can visualize it more easily, and then sort of, letting you do what you will with that. And another thing to note is that this process only requires a sort of, what I would like to say, advanced beginner knowledge of Excel and QGIS, or sort of GIS programs more broadly, because we'll be using QGIS for this example, but I believe all of these particular processes will work for ArcGIS, ArcMap, the sort of Esri suite of products. And that often is the program that is used by transit agencies, things like that. But I purposely chose QGIS #1 because I personally at this time do not have access to ArcMap. And also I think in the spirit of the open source nature of GTFS as a spec, using the open source GIS program just feels sort of more thematically appropriate. Another sort of thing I want to note too is there's a lot of this kind of stuff could be done in Python or R or any sort of other program or software language, whatever you want to call it, that more technical people than myself can and do use. But I purposely wanted to come up with a process that did not require that, because I believe that you should be able to do cool stuff with data without learning how to code. And I think that is sort of a broader complaint I have about the broader open data ecosystem, is that a lot of the cool stuff you can do is predicated on being able to code, but there are a lot of people, myself included, who just have not gotten around to learning Python yet. And learning a language is hard, regardless of whether it's a spoken language or a coding language. And it's not something you can necessarily pick up immediately. So that's why it's important to me personally to come up with options that don't require that and can kind of let you get to that point. Maybe there's a little bit more brute force, maybe not the most absolutely efficient way to do it, but it is another way to do it. And so to actually do this process, the GTFS files you'll need, like I mentioned some of these earlier on in the presentation, but the ones you'll need in particular are stops.txt, stop times.txt, trips.txt, and calendar.txt. And so, yeah, those are the ones that you will need for this one. So unfortunately, this process, it will not work for every single type of feed. So it will work for many to most feeds. I have tried it on a bunch of different feeds, but there's a couple of sort of complicating factors that can make it less useful for certain feeds. So a couple things you want to check in a given feed before you try to dive right in is the calendar file. And so basically, so this particular one is a very good example. It's a small agency, but they have, they have 3 calendars. You can see service IDs of 0, 1, and 2. Service ID 0 is weekday service, because the columns from there on, it's a little easier to see in a spreadsheet. I probably shouldn't have put this one in this text file as a screenshot. But in any case, you can see here that service ID is 0, and there's a 1 for Monday, Tuesday, Wednesday, Thursday, Friday. A 1 means service, a 0 means no service, or rather that the calendar's service ID, there's 3 different service IDs. There's a weekday calendar, a Saturday calendar, and a Sunday calendar. And this is actually very important when it comes to visualizing things, because when it comes to frequencies, you want to make sure that you're you have a certain, you're only displaying sort of one calendar at a time, because you wanted to, and so that it also makes it easier to kind of break things up into different periods. So the example on the right uses the calendar dates.txt file instead. Calendar dates is generally used to show calendar exceptions, where like you may have something like this, the regular calendar file, and there might be another service ID where it has no particular weekdays specified, but it'll show a date, and then it'll say like in the calendar dates, it'll say like service ID 3 is only in use on like Labor Day and President's Day, and it has reduced service or something like that. But sometimes agencies will set up their entire calendar using calendar dates.txt, and that won't really work for this process. It could be done, but I've not gotten around to looking at it, and so not necessarily the best. Another one that won't work is the example below, where there's This agency has a lot of different calendars. It has 2 entirely different calendars within the same feed, the reduced service calendar and the revised regular calendar. It also has a lot of different overlapping calendars between different days. Like there's a Monday through Friday calendar, a Monday through Saturday calendar, Monday through, a full week calendar, just Saturday, just Sunday, just weekend. So there's a lot of weird overlaps in a way that makes it harder to kind of separate things out. So the best ones you want are ones where it's clearly like weekday, Saturday, Sunday, or weekday, weekend, or even just like certain sort of days where it's just clearly defined. And so that will kind of make it easier to weed things out. The other one that you'll need to check before diving right into it is stoptimes.txt. And so stoptimes.txt has the actual, should have every single arrival and departure time for every single stop. And so this is important too. And so the one that says will work, you can see that there is arrival and departure times for all trips and all stops. It won't work if there are not arrival and departure times for all trips. There are a lot of agencies where they may only have stop times for the time points, but generally you will want to have interpolated stop times to actually work on this method. If you want to divide things up at the hourly level, if you just want daily frequencies by stop, it's a little bit less important, but it's still something to keep in mind and take a look at. So this URL, Jordan, if you mind popping it in the chat, that has a document that has step-by-step documentation of what we call the GTFS to GIS process, and it looks at taking frequency data from GTFS feeds, putting it into Excel, and setting it up to aggregate frequencies at the route level and the stop level. And so in this tutorial, we'll be doing just the stop level process, because the route level process is very similar, but it requires a couple more steps that require a little bit more manual labor that are not, it's not really interesting to show in a tutorial like this of, watching me merge all the different shapes down to routes, things like that. A little less fun. And so, yeah, I think we will be moving toward that. If you guys, given that we're reaching the half-hour mark, if a bunch of you guys want to jump ship to go to different talks, go wild. However, if you would like to see us demonstrate this, feel free to stay here and follow along, because you'll get to see some real, nerd stuff in action. And in any case, I'm going to stop screen sharing for a moment because I think I need to change my window real quick. So I'll use that as a 30-second breather. Yeah, thank you all for participating so far, and glad to